Electrochemistry, chapter 19. We're all familiar with electricity. We use it all the time. Sorry, I'm just having some issues. Where does electricity come from? It comes from the power plant, right? So you can generate it using a coal-burning power plant. You can generate it from solar panels, from hydroelectric, from wind power. There's a lot of different ways. But the electricity gets generated, and it comes to your house through what's called the power grid. Sometimes people say, well, he's off the grid. That means you're disconnected from the grid that connects all the other houses together. And the grid has sections, and so, you know, when the tree falls and half of Fowler loses its electricity, all those people were on one part of the grid. And there are isolated sections so that the whole thing doesn't go down. And that's one of the scary things, you know. It's like, you know, terrorism and stuff. If someone were able to shut down the entire power grid, that would be a big deal. So the option of disconnecting from the grid is becoming more realistic. It used to be kind of a extremist sort of a thing. It is more realistic now. If you've got solar panels in conjunction with batteries, you can store the energy from the sun during the day so that you can use it at night. It's not as simple as it sounds. It's not just a matter of, oh, we purchase this system and we're good to go. It takes monitoring and it can be a pain. But it's possible. And more options are being developed. Fuel cell power plants might be a reality someday. These are about the size of a refrigerator, and they can generate power for your home. So that would be cool. So what is a fuel cell? Here's a picture of a fuel cell that might power your home. Fuel cells are very efficient, and they produce less pollution than fossil fuel combustion. So that's a good thing. But, you know, they're not ready for mainstream yet. Fuel cells are based on oxidation reduction reactions. And the most common one is the hydrogen-oxygen cell. And so what powers this one is hydrogen gas reacting with oxygen gas to form water. There's no harmful byproducts from this reaction. You're making water. Can anybody think of an issue with this? Too much water? Explosive. Mixture of hydrogen and oxygen is very explosive, so some precautions need to be taken there. About this, where do you get the hydrogen and the oxygen? Well, you buy it at the store, right? Where does it come from? You have to get it from somewhere, right? And getting it from somewhere is going to require energy of some kind, right? And that might cause some pollution, depending on how you generated that. This is the reaction that powers cars like this one. They now have cars that will run on hydrogen. But again, not ready for everybody to be using it just yet. So what's going on in this reaction here? So hydrogen and oxygen are going to form covalent bonds in the water molecule. But in those bonds, the electron pairs are not shared equally. You should have learned that in Chem 1A. Water's a polar molecule, and you've got polar bonds between the hydrogen and the oxygen. So in effect, the oxygen has more electrons when it's in water than it did as an O2 molecule. And so it has gained electrons from the hydrogen. Reduction is gain of electrons. So the oxygen has been reduced, the hydrogen has been oxidized. This is not a reaction where electrons are transferred one to the other, but it's the electron density is shifting. So in the hydrogen-oxygen fuel cell, the hydrogen, oxygen, and oxygen are separated, and that forces electrons to travel through a wire to create electricity in order for this reaction to occur.